Okay, we're going to be looking at cubic equations today and how we expand them and collect them together. And we're going to start with the basics. We're going to start with single bracket expansions and build our way up to the cubic. So let's look at this problem. This is a single bracket expansion problem because I've got one thing on the outside, just this 5, multiplying together this whole bracket. So in between that 5 and that bracket is a multiplication. So I'm doing one thing, 5 times the bracket. Same thing here, I've got -2 times this whole bracket. So it's single bracket expansion. And what you're probably used to doing is doing your FOIL method, so bouncing this in. And actually, I really need us to move away from this now because this can cause a lot of errors and it gets really complicated when you're trying to do 3 bracket expansion. Instead, we need to be using a grid. So this grid for this question would be a 1x2 grid. So it looks like this. The 5 goes on the outside, and then the P and the 3 go here and here. And if I was doing for the second equation, this would be my grid. And I have a -2 on the outside, and a 1 and a -2P here. So to fill this out, you've got to know that you've got to multiply these grids. So you're multiplying the numbers. And another key tip is if you ever have a letter on its own, put a 1 in front of it to remind you that that's 1p. 1p. So when I do this, I've got 5 times 1, so this first grid, 5 times 1, which is 5, and the p is just there on its own, so 5p. And then the next box along is 5 times 3, so I know the 15 goes in here. This gives me, for this first expansion, 5p plus 15. Next grid, I've got -2 times 1, which is -2, and -2 times -2, which becomes a 4, and there's a p there on its own. So -2 plus 4p. Now you can collect together your terms. So we've got a 5p and a plus 4p. So there's my first family, the 5p plus the 4p. And remember, if you're adding or subtracting, families don't change. So whatever my answer is here, it's still the family of p. So this has to become 9p. Now let's look at our numbers. You've got plus 15 and a -2. So always start by writing the positive number first. So I'm going to write 15 and then the -2. That gives me my 13. So my final answer here needs to be 9p plus 13. Okay, now that's nice and straightforward. Let's do one more to have a look at it. To have a go at doing this by yourself and then play the video to check your answers. Otherwise, watch for one more example. Again, it's 1 bracket expansion because there's just a 3 on its own multiplied by this whole bracket. And the second one, this is a 5 multiplied by this bracket. So my grids are going to look something like this. And here, as my first one, I've got a 3 here and a y -2. And the second one is 5 and a 2y plus 1. And remind yourself, you are going to be multiplying these grids together. And any letters that are on their own, I'm just going to pop a 1 in front of it so that I don't make a silly error. So this first box, I've got 3 times 1y. So this becomes 3y. 3 times -2, -6. Second grid, 5 times 2y. So 5 times 2 is 10, and there's a y with it. And then 5 times 1 is 5. So I'm going to write it all out. I've got 3y -6. And here I've got a 10y plus 5. And this 10y is positive, so I'm going to put positive there to help me out. If you wanted to, you could also put a positive in front of that 3y because it's a positive number. Let's collect our families. So firstly, the family of y's. I've got 3y plus 10y. That's going to give me 13y's. Remember, families don't change. So it's the family of y's. I've got 3y plus 10y, 13y. Next, my numbers. I've got a -6 and a plus 5. So write the positive number first. This is 5 -6. Hopefully we can all see that will become a -1. So final answer here, 13y -1. And you've got 2 marks for it. Okay, this is a foolproof method. The reason I'm asking you all to do this method is because this is an easy 2 marks for the exam. And if you know how to do this method really well, when it comes to 3 bracket expansion, it's going to be a doddle. So here you've got a double brackets question. You've got m plus 7, this whole thing, this whole bracket multiplied by m plus 3. So we're going to use the grid. But this time it's a slightly bigger grid. It looks like this. I'm going to do this one nice and big. Like this and like this. Because now this first one goes at the top. So this one gets an M and a 7. And then this second bracket goes here, M and a 3. And again, exactly the same method. You are multiplying. Drop a 1 in front of any letter that's just hanging out on its own so that we don't make silly errors. And then we do exactly what we've just practiced. We fill in our grid using multiplication. So the first box, 1m times 1m. Really common to write the answer 2m here. It's not 2m. And this is why having this 1 at the front will really stop that from happening, because you need to do 1 times 1, which stays as 1, m times m, m squared. If we move across, we've got 1m times 7, so 7m. And going down, you've got 1m times 3, 3m. And then the last box, 3 times 7, 21. Now, here's why this method is so good. You now go across your diagonals. So my first diagonal is from here to here. What's in that box? On its own, it's a 1m squared. Next one, this diagonal here, okay? Everything in these boxes that's in that diagonal should be the same family. So let's have a look. I've got a 3m plus a 7m. Yep, they're the same family, so I know I'm doing the right thing. Becomes a 10m. Last diagonal here, 21. On its own, 21. Which means that my final answer is these combined. 1m squared plus 10m plus 21. Okay, foolproof way of working that out. And when we move on to this next question, you can see straight out it's a harder problem. We've got 3 brackets, but the method is exactly what we've just done. So you don't need to learn any more maths, you just need to apply that method. So let's start off by expanding out the first 2 brackets, just like we've done before. A nice big grid. If in the exam they give you a tiny amount of space to answer this question, don't try and fit it in that space. Ask for normal paper or use the space that you've got to really make sure your method is clear. So I want a nice big grid. Here we go. So the first 2 I'm expanding are 2x and a 1. And here an x and a 3. Write it in that you're multiplying to remind yourself. And then drop the 1 in front of here. So when you come to check your answers, you know exactly what you were doing. So first box, 1 times 2 is 2. X times x, x squared. Next box across, 1 times 1 is 1, and you've got this x here. Going down, 3 times 2 is 6, and you've got the x. And then you've just got 3 times 1 on its own, 3. Work the diagonals. First diagonal is just 2x squared. Next diagonal, all should be the same family. If they're not, you need to go back because something's gone wrong. I've got a 6x plus a 1x, giving me 7x. You can write these in any order you want. You get the same answer. So here I did 6x plus 1x, 7x. And the last diagonal, 3. So final answer here, you're taking this guy, and this guy. We've got 2x squared plus 7x plus 3. Now, I've put this in a bracket because we're not done yet. You've got one more bracket to put into this scenario. You've got this 3x plus 7, so I'm going to put him here, 3x plus 7. Same method. Nothing's different except for now you have in this first bracket 1, 2, 3 terms, all being multiplied by the second bracket, 1, 2 terms. So your grid's going to get slightly bigger, but that's okay. So let's have a look at this. It's going to look something like this. It's a little bit small, but we can work with it. So 3 boxes, because now I've got a 2x squared, a 7x, and a 3. And at the top, I've got a 3x and a 7. Remind yourself you're multiplying and just pop a 1 in front of any letter that's on its own. Haven't got any of those here, so I'm fine. So I'm going to start with my multiplication. So in the first box, I've got 2 times 3, which is giving me 6. X squared times x, x cubed. Moving across, 2 times 7, which is 14. And I've got this x squared on its own. Next one, 3 times 7, 21. X times x, x squared. Moving across, 7 times 7, 49. And then you've got the x on its own, so x here. Going down, 3 times 3 is 9, and you've got an x there. In the last box, you've got 3 times 7 again, giving us 21. Now, here's the magic part of this. If I now work my diagonals, it really makes sure that I'm not making any errors. First diagonal, 6x squared. Sorry, 6x cubed. So done. There we go. Next one. Down this guy. Should be all the same family. So let's check it. I've got a 21x squared and a 14x squared. Same family, so I'm good. And I can do 21 add 14, 35x squared. Next diagonal. I've got a 49x plus 9x. 58x. And then the final box, 21. So I've got 21 here. What does that mean? Well, that's my final answer done. This guy, this guy, this guy, and this guy are what we'll get when we expand it. So my final answer on my page, I should be writing, is 6x cubed plus 35x squared plus 58x plus 21. So what was a really complicated problem actually is nice and straightforward using one method that I can use for single, double, or even triple bracket expansion. Let's keep going so you can see it again. If you're feeling super confident, you want to have a go at it yourself, that's fine. Have a go at this next question, pause the video, and then watch it back to make sure you got the right answer. Otherwise, if you want to see one more, that's absolutely fine. You can follow me. So we've got 3 bracket expansion, so we're 3 marks in the exam. It's worth pointing out this type of question is most likely to come up on the non-calculator paper. So even when you're doing your multiplications here, you need to be doing it by hand on paper, not using a calculator. So first things first. First 2 brackets, let's expand those guys. So these 2 are what I'm going to expand first. I'm going to draw myself a 2 by 2 grid, like this. And I've got an x plus 1 on the top, and I've got an x plus 2 on the bottom. And actually, it doesn't matter what order you write these in. If you put the x plus 2 on the top and the x plus 1 along the side, you get the same answer. Just going to drop a 1 in front of these x's to make sure I don't make a mistake. And now I'm going to start my multiplication. So in the first box, I've got 1 times 1, so there has to be a 1 there. X times x, x squared. Moving across, 1x times 1. Well, any number times itself is itself, so that stays as 1x. Then I've got, moving below, 2 times 1 is 2, and the x there, and the last one, 2 times 1, which is 2. Go down our diagonals. First diagonal, I should get 1x squared on its own. Second diagonal, I've got a 2x and a 1x. Should be the same family, which they are, so I know I'm doing well. We should get a 3x here. Last diagonal, 2 on its own. And that's great. So there's my first expansion. I've got a 1x squared plus 3x plus 2. And now I'm going to bring this last bracket all the way down to finish this question off. So this is x plus 3. So now I've got in this first bracket 1, 2, 3 terms. In the second bracket 1, 2 terms. So I know when I come to draw my table, it's a bit like this. On the top, I'm going to have the x plus 3. And down the side, I've got my 1x squared, 3x, and 2. Remind yourself that you're multiplying and drop a 1 in front of any letter that's just hanging out on its own. Right, let's do some multiplication. So first things first. 1 times 1 is 1. X squared times x, x cubed. Moving across, 1 times 3 is 3, x squared, hanging out on its own. Going below, 1 times 3 is 3, x times x, x squared. Moving across, 3 times 3 is 9, and you've got the x there. Last row, 1 times 2 is 2, x, and the last box, 2 times 3 is 6. Right, this is where we make sure that we're getting everything in the correct place. First diagonal, 1x cubed. Second diagonal, check you've got the same families. I've got a 3x squared plus a 3x squared, so it's looking good. 6x squared. All the same families again. These are not going to change when we're doing adding or subtracting, you're just collecting together. next diagonal, you've got a 2x and a 9x. Same family, so I know I'm on the right track. 11x. And finally, 6. So collect that all together and you've got your final answer. To get your 3 marks, you need to be writing 1x cubed plus 6x squared plus 11x plus 6. And you're done. Okay, easy 3 marks there. Easy 3 marks. Right, we're going to go through a few more examples just so you can your work and you've got something you can watch. This next question, really common in the exam. It throws people off because it looks so complicated, but actually they're asking you to do exactly what we've been doing. It says, show that this side, 3x minus 1 times x plus 5 times 4x minus 3 equals this thing, which looks super complicated, but it's actually just exactly the same. 12x cubed plus 47x squared minus 62 plus 15. So I've got to show that when I expand these 3 brackets, I get these numbers. So actually, it's giving me the answer that I need to get to. So let's start by expanding it out, because that's what I know I can do, and I can do it really well. Start with these first 2. A nice 4x4 grid. 2x2 grid. And you've got 3x and a minus 1. And across the top, I'm going to put the x and the 5. Remind yourself you're multiplying. Drop a 1 in front of any letter that's on its own. And let's start filling in the table. So 3 times 1 is 3x squared. 3 times 5 is 15x. Moving down, 1 times minus 1 is minus 1x. And finally, minus 1 times 5, minus 5. Head down the diagonals. So first one, 3x squared. Next one. Now, here's a good tip here. You can write these numbers in any order you want. I always start with the positive. So I'm going to start with the 15x minus the 1x. 14x. Last one, minus 5. So if I'm going to write that out, what do I know I've got? A 3x squared, a 14x, and a minus 5. So I'm going to write 3x squared plus 14x minus 5. And then I've got to bring my last bracket, this guy, all the way down. So here he is, 4x minus 3. And now I get on with doing the exact same thing again, just in a slightly bigger table. So here's my table. Let's go there and there. So it's easy to see. So across the top, I've got 4x minus 3. And down the side, 3x squared. 4x. Let's try that again. 4x. Oh no, it was 14x and minus 5. Right. First grid, I've got to remind myself I'm doing multiplication. I'm going to drop a 1 in front of any letter that's on its own. I haven't got any of those, so I'm good to go. So first grid, I've got 3 times 4, which is 12. Then I've got x squared times x cubed. Moving across, 3 times minus 3 is minus 9. X squared, no change. Moving down, I've got 14 times 4, so I need to do that working out. So I'm going to do it nice and big here. 14 times 4. Well, 4 times 4 is 16, so I put the 6 there and the 1 in the bracket, in the bag. 4 times 1 is 4, add the 1, 56. So I know in here I've got 56 and x times x, x squared. Moving across, I've now got 14 times 3. That's okay, do exactly the same. 3 times 4 is 12, so I put the 2, carry the 1. 3 times 1 is 3, add the 1, 4. So I've got 42, so this becomes 42x. And it's actually a minus 42x, so I've got 14 times minus 3. Last box, last row, I've got minus 5 times 4, so minus 20. X, and finally I've got minus 5 times minus 3, positive 15. Okay, let's work down the diagonals. So first diagonal, Nice and easy, 12x cubed. And that should make you feel good, because if you look at what your answer should be, up here, I needed a 12x cubed. So things are looking nice. Next one, this diagonal here. Remember what we said, start with the positive number. So I'm going to start with the 56x squared minus the 9x squared. What do I get? 47x squared. Again, pretty happy with that, because I know that I need my answer to be up here, 47x squared. Next diagonal. They need to be the same family. Right, this time they're both negative. So I've got minus 20x and a minus 42x. So it doesn't matter what order you write this in. I'm going to go minus 42x minus another 20x. And I'm at minus 62x. Again, quite pleased with that answer, because I know that that's what I wanted up here. And final diagonal, 15. So tidying it all together, I've got a 12x cubed, a 47x squared, a minus 62 and a 15. So I have shown exactly what they wanted me to. I've shown that when I expand it out, I get 12x squared plus 12x cubed plus 47x squared minus 62x plus 15. So 3 marks are in the bag. Let's keep going, we've got more to practice. We've got 3 brackets, x plus 2, 2x minus 3, and 3x plus 1. 3 marker in the exam. Start with the first 2 brackets. Nice grid. Here we go. And you've got an x and 2 here, and a 2x minus 3. And this is another good one for looking at minuses. So we're going to times them. We're going to put a 1 in front of here, because it's going to help me remember to multiply. So in the first box, I've got 2 times 1, which is 2, x times x, x squared. Moving across, I've got 2 times 2, which is 4, and the x stays the same. Going below, I've got minus 3 times 1, stays as minus 3, and I've got x on its own. And final box, I've got minus 3 times 2, minus 6, and I'm ready to work on the diagonals. First diagonal, 2x squared. Second diagonal should be the same family. I'm going to start with the most positive number, so 4x minus 3x, 1x. Final diagonal, minus 6. Taking that all together, you've got 2x squared plus 1x minus 6. And now you've got to bring this last bracket all the way down to finish the question off. So I've got a 3x plus 1 left. I'm going to build a 2 by 3 table like this. Across the top, I've got 3x and 1. And down the side, I've got a 2x squared, a 1x, and a minus 6. Remind yourself you're multiplying. Pop a 1 in front of any letter that's on its own, and we're good to go. So first grid, you've got 2 times 3, which is 6, x squared times x, x cubed. Moving across, 2 times 1 is 2, and the x squared stays there. Going down, 3 times 1 is 3, x times x, x squared. Moving across, 1 times 1 is 1, and you've got x here. Last row, you've got minus 6 times 3, so that becomes minus 18, and you've got the x that doesn't change. And in the last box, minus 6 times 1, minus 6. Work down the diagonals. So the first one, on its own, 6x cubed. Next diagonal should be the same family. You've got a 2x squared plus a 3x squared. 5x squared. Remember, you're collecting the family, so the family is not going to change. That is the family of x squareds. Next diagonal, you've got a minus 18x and a 1x. So start with the positive. So start with the 1x minus 18x. Hopefully that's going to make it obvious as the answer is definitely negative. It's minus 17x. Final diagonal, minus 6. So final answers here. You've got 6x cubed, 5x squared, minus 17x, and minus 6. So you're going to write it out. 6x cubed plus 5x squared minus 17x minus 6. There's your final answer. Super easy, 3 marks in the exam. Okay, I think we have one more. So last one for this topic. Expand and simplify x minus 2 times 2x plus 3 times x plus 1. So let's take these first two. Nice 2 by 2 grid. I've got an x minus 2 and a 2x plus 3. You're multiplying. Stick a 1 in front of any letter that's hanging out on its own. So in my first box, I've got 2x squared minus 4x. Going down, I've got 3 times 1, which is 3x. And across 3 times minus 2, minus 6. Working on the diagonals, first diagonal you've got is 2x squared. Second diagonal, remember, write the positive number first. So I'm going to write 3x minus 4x. So that's giving me a minus 1x. And the last diagonal, minus 6. Putting that together, that gives you 2x squared minus 1x minus 6. And then I'm bringing this bracket down, x plus 1. Let's build the grid. So this is a 3 by 2 grid. Across the top, I've got the x and the 1. And here I've got 2x squared minus 1x and a minus 6. We're multiplying. Stick a 1 in front of any letter that's just hanging out on its own, and let's go. So 2 times 1 is 2. X squared times x, x cubed. 2 times 1 is 2x squared. Moving down, I've got minus 1 times 1 is still minus 1. X times x, x squared. Moving across, number times number, minus 1 times 1 again, so still minus 1, and this time just the x. Final row, minus 6 times 1 is minus 6, and there's an x there. And the final one, minus 6 times 1, minus 6. Let's go down our diagonals. First diagonal, 2x cubed. Next diagonal, remember, write the positive number first, so 2x squared minus 1x squared. That's giving me 1x squared. Next diagonal, you've got minus 6x minus 1x. So both are negative, so it doesn't really matter what order you're going to put it in, but I would probably write it as minus 1x minus 6x. So I'm at minus 1 on the number line, and I'm going down another 6. So I'm at minus 1, I'm going down another 6. My answer is definitely going to be negative, minus 7x. And finally, minus 6. Pulling it all together then, you've got 2x cubed, you've got 1x squared, and minus 7x, and then minus 6. You're going to write that answer out in full. The answer is 2x cubed plus 1x squared minus 7x minus 6. So that is expanding brackets, and you need expanding brackets in so many different places, not only on the 3-mark questions that they give you like this. You'll need it for solving equations. You're going to need it for sketching graphs. You're going to need it for rearranging equations. So this grid method is essential. It comes up when we look at surds. So picking this up and practicing it now is going to make a great foundation for you when we start moving on to the really hard, complex stuff. Well done, everyone, and I will see you soon.